Next, weight. Okay, see, weight of the body. What is the weight of the body? The force of attraction. See, normally what happens? Force of attraction F is equal to m into a, will say. See, whenever an object which is falling towards the ground, at that time so give the force F is equal to m into g. Means here freely fall, I am saying that you are not applying any force, means whatever the weight is that is making it to move downwards. That's why weight W which is given as m into g. Weight W which is given as m into g. If the body is of 1 kg, the weight will be equal to 1 into 9.8. If body of 2 kg is there, means W equal to 2 into 9.8. Weight, the mass of 3 kgs it is there. 10 kgs is there. 10 into 9.8. Weight will be depends upon the mass of the object. Weight will be depend upon the mass of the object. Now next, can we measure the weight of the freely falling body? Can we measure the weight of the freely falling body? For example, what you do, this is the activity you can do at your home. See, when I am trying to measure this on a spring balance, I have given a weight of somewhere around 1 kg or 2 kgs or 3 kgs. When I am measuring, when I fix it to the seal of a wall and just hanging it like this, something means at that time the weight will be shows you something 2 kgs it will be shows you. What I am doing that after showing something like that, I am trying to release that from particular height. When I am trying to release that from a particular height, what happens? Whatever this reading is there, it will be goes directly up, which is shows you the indication as 0. Means here weight of freely falling body is 0. Weight of the freely falling body is 0. Means when it will be shows you the weight, okay, normally it is hanged, at that time it is showing you the weight. When you released from the particular height, it is 0. Means here whenever if you are falling on from a particular height, your weight, you will feel is a weightless. You will feel is a weightless. Means for example, on a sliders or anything else, you will be going easily, means something like you will feel a weightless due to that. When anything is dropped from particular height, it will be shows you as 0 because of acceleration due to gravity. Because of acceleration due to gravity. Next, see here, observing the activity 6, observing the changes in the freely fall of a body. Freely fall of a body. I am taking a ball in which I am making a holes over here. In this hole I am fixing the rubber bands. So many rubber bands I can fix it. It can easily balance somewhere around 1 kg of stone, you can say. Balance the 1 kg of stone. See what I am doing, I am trying to drop a stone from particular height. When I am trying to drop a stone from particular height, initially what happens, whenever dropping, whatever the stone is there, it will come down and after a few seconds it will be balanced on that. Why it is coming down? It can easily balance 1 kg, means whenever you are trying to drop from particular height, it weight will be get increases. It weight will be get increases. Means here I already gave the formula. Weight is equal to mass into acceleration due to gravity. Acceleration due to gravity will be acts on that. Due to that, whenever it falls at that time. After that, what happened? Acceleration due to gravity will be reduced as the on the band only it will be stable. Due to that, acceleration due to gravity will be decreased. That's why because of what happened, it will be stably on the that only, it won't be jumping. See, that's why what happened, whenever the any person jumps on any bed or any spring anywhere, he'll be jumping like that only due to the acceleration due to gravity. At one particular point, due to exactly support whenever it got, at that time it means that only I'm saying, a person whenever he is trying to jump, he'll feel is the weightlessness, but the force will be there. Due to the force, it will goes down and it will comes up. It will goes down, it will come up. Okay, see, when a body freely falls, it experiences the weightlessness. Even in this weightlessness condition, there is a still gravitational forces acting on the body, causing downward acceleration. But because there is a no support of force, the weight appears to be 0. There is a no any support of force, because of that weight is appearing as a 0, but still the force is there. Due to that force, means here weightlessness means anywhere if you are falling, you should not get hurt, means it is not a possible. The force will be there. Whatever the force is there, the force is because of acceleration due to gravity. The force is because of acceleration due to gravity. Due to that, the person will feels weightlessness. Okay, he is giving in when is your weight will be equal to mg, saying write this, think and discuss and send it to Mima. Give example for weight of the weight when your weight is 0. Just now we talked about that. Now coming to the center of gravity. Center of gravity. What is center of gravity? In that first we are balancing a spoon. Balancing a spoon and a fork. What I am doing, spoon and fork, just fixing something like this, which is shown in your book. For that I am fixing a matchstick and trying to balance it on a glass. You can balance that. How can you balance that? If you know the wherever the center is there, that center, if you know that, you can balance it easily. If you know the center wherever it is there, then you can balance that easily. Where we know the center, that's why I'm saying that wherever the center is there, completely force and weight will be acts over there, it will be get balanced. Now one more thing, try it your home. Sit on a chair, touching your back to the chair and keeping the knees something like this, without bending your knees. Without bending your knees, try to stand up. Try to stand up. You can't stand. If you bend the knees, you need to shift your weight center of gravity from one place to the another place. If you shift to that, then only you can get up from that. But whenever you are trying to sit, your wherever seat is there at the back, completely your center of gravity will be present over there. Whenever you try to get up without bending, you can't get up. Whenever you are trying to get up, what happens? You need to bend your legs and you need to bend yourself. At that time, the center of gravity will be shifted from one place to the another place. At that time only you can get up. Now one more thing. Okay, balancing a ladder. Normally, see, the person who carries the ladder, he will be catching exactly at a single person will carry the ladder. He will be catching exactly at the center and he will carry. If he carry at the end, other end, he can't carry that. It will be, he'll feels very heavy weight. That's why the person who will be carrying, he'll be seeing the center most point and he'll be carrying that. Due to that, he can easily carry the. He know the center of gravity of the ladder. How many holes are there? Based upon that, he'll call exactly at the center hole. He'll be catching that and he'll be taking the ladder. That is nothing but a center of gravity. Next, locating the center of gravity. Locating the center of gravity. See, normally a straight line is given, a particular shape is given. At that time, it is easy. For a scale is there means number, you normally 15 centimeter scale is there means wherever 7.5 is there, there. Okay, 7.5 is there. 30 centimeters is there means in 30 exactly half is 15. Wherever the 15 is there, if you keep your finger in, you can try to balance the scale. Means here where we know the center of gravity, we can count it and we can measure that and we can calculate the center of gravity. Now coming to the irregular shapes, something like the shape is something like this. Something shape is like this. What is, how can you say that where is the center? If the particular shape is there, you can easily identify this is the center and you can calculate it. But shape is different. If in the time you need to choose the borders, ends, completely ends, what are there that you need to choose it and draw a diagonals to that. Wherever the diagonal is meeting, that will be considered as your center of gravity. Center of gravity. Like this, for India map, you need to draw the center of gravity. Where will be the center of gravity is there? Means you need to choose the four ends and you need to calculate. Identify the center of gravity of the ring. How can you identify the center of gravity of a ring? This thing, you need to do the activity and you need to send it, ma. I want it from your side. How to calculate the center of gravity of the ring is saying. Means for this I set the four edges. For this, where are the four edges? I don't have the four edges. How you will calculate the center of gravity? I want to know. Okay, you just send the answer for this. You need to draw the circle and how you are doing. Just say me in explanation and you send it to me, ma. Okay, next. And last topic is your stability. Okay. See, stability. The location of center of gravity is important for stability. Where the center of gravity is there, that is very important. Based upon that only the person's stability will be defined. If you are doing so and so exercise, okay, if you are doing so and so exercise, means compulsory we need to know where the center of gravity is there. See, for example, person is sitting or standing. If his center of gravity is not at a fix, he can't sit properly. If the center of gravity sit, he can sit for many. Then you know the center of gravity, he can balance. See, for example, if you know the center of gravity of this pen, I can balance for many times. If you know the center of gravity of pen, I can balance it. If you don't know, it can be balanced. It won't be stable. Either it will be false or anything else. Okay. The line through the center of gravity falls outside the base. then object will be unstable. Wherever the center of the gravity is there, that then if it is outside that, it will be unstable. Finally, shift of the center of gravity and its effects. See, for example, a person is bending and catching the toes. What do you do it? This is a wall, completely stick it to the wall. From your legs to till back, just stick it to the wall and try to touch your knees. Do it your home, no one is saying. Okay, touch your toes. Whenever you're trying to touch your toes, at that time you can't touch your toes. If you, even though you're trying to touch your toes, you will be falling down. What happened? Your completely center of gravity is present with the legs. Okay, whenever you're trying to stick it, your center of gravity is shifting from one point to the another point. It is shifting from here to here. That's why what happened? You are falling to the backward. That's why you are falling towards the forward direction. This is about your stability, which how the center of gravity is shifting from one point to the another point. This is your universal law of gravitation. Complete the notes and send it to me, ma. Thank you.